So hello from me, my name is Jan, aka Pospa, and as you heard, I'm from Microsoft, but I'm not the sales guy, so no marketing bullshit or whatever. So this will be purely technical, but I'm not a data scientist, like I'm not that deep into the statistics, so I will show you, and I'd like to demonstrate how you can use one of our technologies named Azure Machine Learning for machine learning, of course. But in case of any really deep technical question like how about this model, how about that model, how some R packages and stuff, maybe I will be unable to answer, but those questions can be sent over to me through email, and I will hand over those to my colleagues who are really focusing on those stuff. I'd like to have that session interactive as much as possible, so in case of any unclearness or in case of any question, just feel free to jump in and ask a question. Before we start, I'd like to know, like, what's your area of expertise? Are you more into the data or into the business logic or into the whatever? So, and based on that, I can reshape my speech a bit. So who is really the data specialist? And who's more business oriented? Okay, and how about you guys? So kind of academic, right? Okay. And I think you also, Okay, so there will be special section about how to implement it into the third-party system as well. Oh, okay. No, sure not. I just want to think through how should I put those things together, because this will be, to be honest, just kind of high-level overview. Because the machine learning can be like for 3 days talk and then another 5 days hackathon or whatever. So I will just show you what's possible, how you can use it, how you can, let's say, not buy it, but how you can access even like for free, and some very basic first step to let's say ramp up you to some basic level of knowledge of that system. And everything will be just practical. So there is a prerequisite that you know what the machine learning is, or at least you have some basic knowledge about the data science. So machine learning is another brand new thing in our service portfolio. It's kind of new, but there is some research behind, and don't take it wrong, but even the whole Bing engine, the whole Cortana engine is running on top of the machine learning. So every translation, every search, every whatever is related to Cortana is running on top of the Azure machine learning. So I'm saying that just to introduce that this is not something like, okay, now it's cool and sexy, we should have something, but there is really some advanced analytic and advanced research in it, and you can really use it for even the really that much technical stuff as deep learning and stuff like that, but we will get to the point. So, first of all, if you want to try anything I will be showing to you, you can access address like studio.azureml, like Azure Machine Learning, .net. This is the landing page. And for the first try, you don't need to even create account or anything like that. There's a program, like 8-hour trial, and for that you don't even need to have any Microsoft related account or anything like that. Then in case you find it useful or beneficial for you, then there are some others, but yeah, I'd like to keep it just purely technical. In case of any question which are not directly related to what I'm showing to you, feel free to reach me through email. And my email is janpos, at microsoft.com, or you can find me on Twitter. So, 8-hour trial will be good enough to do all the demos I've prepared for you. So, let's start with very basic predictive experiments, or everything is called experiments in Azure Machine Learning, but basically it's a pre-train or not yet, but will be pre-trained model of your choice. What's really useful, or what's really put that tool on top is the fact that you don't need to do any installation. You don't need to have any special UI, any special system, or anything like that. The UI is purely web-based. So the web browser supporting HTML5 is enough to interact with the Machine Learning Studio. Every computation, even the heavy computation for the training, is running at Azure. So doing that, you are able to train even like very sophisticated model, taking into the consideration billions lines of data as quick as this, because under the hood there is a big high performance computing farm doing all the computation, and everything is just for, let's say, a reasonable price. So pricing is, and this is only, let's say, price-related thing, is based on computation minutes. So every time you spin up the training, you are paying for that amount of power, CPU power, you are consuming. So let's start with the simplest model you can create. I will focus mainly on predictive models, but you can do whatever. You can do clustering, you can do all other type of models, and I will be back to that a bit later. First of all, you have to have some data. There are numbers of options how you can put your data into the system. The first and most easiest way is to pre-upload your data set directly into the Azure Machine Learning Studio. So you can take your CSV, R data or whatever, and upload them from local computer to the system. It's not available in the 8 hours trial, but in free trial it is available. The second option, because not every time you willing to upload the data to some third-party system, you can use some kind of data reader. Which can take the data from SQL server or from any RESTful API. I'm not sure if, let me adjust the resolution a bit. Yeah, seems to be a bit better. Yeah, much better. So, number of options from where you can take the data out of and load them into your system. And using the dedicated SQL or some RESTful API, you don't even need to store the data inside the Azure. It could be like, okay, the data are pulled from the system, go through Azure Machine Learning, extracting just some metadata, and then the data are thrown away. So no leftovers, no sensitive data ever stored inside of the system. The same is with the output. So you can put the data into the Azure or take them out again through some SQL connection or any RESTful or OData protocol out to your system. There are some other options how to, let's say, incorporate your pre-trained model into your system, and I will get to that bit later. So in the demo, we will be working just with preloaded data sets. No. What the fuck? Perfect. So there are some test data. This data set contains some information about the US population. There is a sample containing age, work class, social status, etc., etc. And the very last column, which will be important for us, is income. It could be like more than 50K per year, or less or equal to 50K per year. So I'm gonna create the predictive model which will be able to predict if we put enough information about some person, able to predict what should be his or her income in the case of US employment. So this is just for demo purposes, but the steps you have to take to create that model will be exactly the same for, let's say, any challenge you'd like to achieve using the Azure Machine Learning. As you can see, everything is like drag and drop only. You don't need to write a single line of code. Of course you can, in case you'd like to extend your model with some functionality which is not there yet. You can use R or you can use Python. Both are fully supported in Azure Machine Learning. There are some Python modules and R modules. In our case, everything which is built in will be just enough to do the training. So firstly, we need to split the data to have a training data set and to have a data set to do a verification. I will do just a very basic model with no, let's say, amendments, and then we will try to play with a bit. Train. Then we have to do some training. Then we have to score and evaluate. So for first data set for training, or first part of data set, the second part of data set for scoring, and then to have some visualization about the model performance, we need an evaluation. The very last thing is to choose which model will be used for the training. There are 4 groups of models you can choose machine learning in here. And those 4 groups are anomaly detection, classification, just for reference. Anomaly detection can be used for some, I don't know, typical cases are some fraud detection for credit cards. It's really looking for any anomaly if you're in your data set. Classification, we will use the classification in this case because we'd like to classify the data we will be putting into with the 2 different values, like okay, under 50K or over 50K, so we'll use the classification in this case. Then there's a clustering which can find some data clusters, it can find some similarities, it can be used for, I don't know, imagine you have a web shop or even some retail shop, like classical one, and you like to define the categories for better navigation through the shop. So you can use the clustering to find some clusters or groups of similar goods which can be put into those categories. Or you can do some classification over, I don't know, population to define whatever. And then regression models, I think those are most common and most known. And I think we can use even the regression for this particular case. So, okay, we will use both. Under each and every section, there is a number of different models you can use. In this case, I'd like to use the neural network because this is the one representing the typical machine learning stuff. But there are also some decision trees, decision forest, and whatever. I don't want to spend much time over those because it's, as I said, not part of my expertise. So neural network regression, and as I said, we will create 2 of them. So the second one will be classification, and again we can use just 2 class because there are 2 possible answers. So 2 class neural network will be enough, and we have to double just this, so Control C, Control V. Okay, same data inputs. And even the visualization will be done over the first model to have really like side-by-side comparison. Very last thing we have to put into our model, and this is really the last one, is to specify what the features will be and what the label or labels will be. So let me specify the label. In this case, it will be column name income, I hope. Yeah, income. And if I set it like this, everything else will be taken as a features. So all other columns will be taken as a feature. So it's really that easy. And by doing that, we can start training. Any questions so far? Okay, so in this case, we do have like just few dozens, thousand of lines in the table, so it's not that complex. But even the calculation with that complexity can take even few, maybe dozen minutes or a couple minutes on local machine. But running in Azure, there is some initial time, like up to 20 seconds or something. And then few, maybe even 1,000 CPUs are spin up and taken into the calculation just for you. So if you have model which should be recalculated every day or something like that, but you don't have enough computing power to do that locally, like on-premise, you can, and because of that, you are recalculating just once a week, once a month, or whatever, you can take that, that problem into the Azure and speed it up. So now we don't have, oh fuck, why that? Same learning, yeah, that's right, I'm mixing up two completely different models. I'm mixing the regression, so we have to have another evaluation, but it's not a problem. In case like this, I mean, if you, because I made a mistake and I need to recalculate the whole model, or I need to recalculate, not the whole model will be recalculated. As you can see, few of those boxes are already having that green tick. It means there are pre-calculated or already calculated. So if I rerun, all those will be just, let's say, confirm that nothing changed, and the calculation will be done just over those boxes and all over those part of the model which were not calculated yet. So done. So let's take a look. So no tuning, no amending. So what the results are? Maybe take this one first. So, as you can see, you do have all the numbers you'd like to see as a data scientist or as a statistician. But in my case, because I'm not saying that I doesn't understand them at all, but I'm not that focused into that, as I said before. So for me, the accuracy is the only number for now which I'd like to see. So our model is accurate like 80%. So in 80%, the answer was lined up with the control data set. So we can, let's say, generalize like the accuracy of the whole model even for new values should be approximately 80%. So 80% is kind of like above the average. Just for reference, if the accuracy is like 50%, then it's equal random. If it's over 85 or 88, you can be sure that you have some mistake in your model, because accuracy like that is like, it's like a dream. So the red flag if the accuracy is too high. So basic model and what we can do next. So any questions so far? Perfect. In case you have some business overview over the data, you can tweak the model a bit. And for that, maybe let's start with, okay, with tweaking. Metadata editor. There is a number of options how you can tweak your model. The first and simplest one is to, let's say, add some metadata into your data set. So we can amend the data set and specify like, okay, not all the data not all the columns will be used as a features. Let's use just few of them because those are having significant impact on the output, because we do have some business knowledge over the data, so we can take few of them. Maybe this for sure, this for sure. It should be enough. And at top of that, you can specify even the data type, because better understanding of the data set can help machine learning be even more accurate, more precise. So you can tweak the input data. This is the first way how you can amend your model in comparison to just purely calculated one. So the first option, metadata. The second options are common tasks like parameter sweeping. This is also like easy and simple to implement and bringing like huge amendments to the model. So parameter sweeping. This one, and for that we need to resplit or even partition the data. So let me delete the second model just to clean it up a bit. So not this, not this, not this, not this. So parameter sweeping, so instead of this box for data training, we will use the parameter sweeping instead, or we will use the same calculation but together with parameter sweeping, and for that we have to resplit the training data again. And let's see what the output no. What the output will be. Let me delete this one for now. Of course, we have to specify what the label is, and the label is income. Another benefit of using machine learning in cloud in general, it is not specific to Azure machine learning only, is like, because you have literally endless computation power available for you, or nearly, then you can use that luxury that you can compare multiple models over the parameter tweaking or data tweaking. So if you are not sure, you can create 2, 3, I don't know, 20 different models and let them calculate at once. It will take approximately the same time as training just one single model. And by doing that, you can find the one giving the best result, even not fully understanding the given data. So, okay, let's see if I tweak it up in a good way or bad way. 84, a bit better. I think it's not because of adding some metadata. I'm pretty sure that it's because of parameter sweeping. Another common task could be like, instead of splitting data, we can cluster the data to have better result from parameter sweeping, and etc., etc. So all the common tasks which you are familiar with, or which is, let's say, widely used for predictive models, are already prepared for you. As you can see, there is a number of possible transformation, feature selection, and whatever, and those are built in and can be used like out-of-the-box experience. I don't like to go through all of them because you can use some reference guidance for that. And as I said, this should be really just like overall high-level overview about what the machine learning is and how it can be used for you. In a lot of cases, you can have your model already created, or maybe even pre-trained. So how about to move it to Azure to, let's say, take advantage of that high-performance cluster which is under the hood? For that, as same as for custom models which are not implemented yet, you can use those R modules or Python modules, as I said before. Okay, not available in free trial. Then let me later switch to the free trial, where I can demonstrate how it can be done. But there are two, let's say, modes how you can achieve that. The first one is interactive. There is a real editor where you can write down your code. Or the second options, and both are listed, you can pack all your scripts, even all your own libraries, third-party libraries which can be referenced from the internet, should not be part of that package. So you can pack all of them together in a zip file and upload just one single zip file into your system, not like, say, copy-pasting everything through that interactive windows. And the same for Python. So anything you have already prepared or you can find on the internet or whatever in Python or R can be used inside of the machine learning. By the way, like 2 months ago, maybe 3 months ago, we kind of acquired the group which created the R language, and those guys are working on the machine learning at the moment, creating the new packages and let's say tweaking the existing packages. So you can be pretty sure that those models which are built into the machine learning are really just not the top, but from the top you can find. There are even some third-party libraries like OpenCV, which can be used for image manipulation and stuff like that. I've mentioned the deep learning. So the deep learning, same as convolution network, can be also created and used inside of machine learning. Because I'm not the image processing guy, I can show just some already done and prepared example. Maybe this is a good point. This is actually a great point. Experiment. There is a list of samples which you can take as a learning materials. I think there is like 100 of them, maybe a bit more, but let's say huge number of existing experiments from which you can learn how to use this, how to use that, how to achieve some specific business scenarios, because there are even some business scenarios covered by those samples. And one of my favorites, it's a predictive model for Titanic survivors. So all the data of all the passengers are preloaded and was used for pre-training the model, so you can enter your own personal data and you will get your chance for surviving the Titanic. But not just those funny ones. There are some, as you can see, really the real world scenarios and samples which can be taken, as I said, as a learning materials. Okay. So at the moment we have a trained model. So what's next? Now you have two, let's say, options how you can use it. The first one is use it like out of the box, not connecting to any third-party system. So same as we can download or upload the data from and to machine learning, we can use the same functionality to download some model which need to be evaluated, and the result again upload to some, I don't know, SQL, whatever. Or you can create a web service which then can be used, can be consumed by any third-party system. So for that, there are two other, let's call it boxes, like a web service input and web service output. So we have to connect them to the correct place. So this represents the pre-scored model because we like to have even the probability. So let me connect in here. And by rerunning, I can create my own personal predictive web service. Seems to be done. Yeah. So I can create the predictive web service. So we do have our training model, which is the one we've created. So this is the original model. And then we have a predictive experiment having those inputs and output. Okay, let me switch to the paid one or to free trial because this is really important. So, not this one. Portal Azure.com. Give me a sec. Okay, why not? First, I have to create a machine learning environment, but it should take just like a couple of seconds only. Machine learning, yeah. Which one? This one. I can use this one. By using that one I've created before, we can like take advantage of fact that there are some already pre-trained models which we can, I hope, published immediately. Yeah, we can. So let's consider this one as our model we've created before. And once it's done, we can deploy the web service. So let me deploy. In this case, redeploy because it's already deployed, but we can redeploy. It takes time because under the hood there is a brand new web, the whole new web has to be created, everything has to be preloaded, so few virtual machines has to be created and spin it up and preloaded, so it can take, I don't know, up to 2, 3, maybe 5 minutes maximum. In the meantime, we can take a look. Yeah, there is one already deployed. So let's consider that this is the one. And as you can see, there are two methods, the request response and batch execution. So let me click through. And what happened? The machine learning created a RESTful API sitting on this address, having some application secret key which can be used as an authorization token. This is the one. This is the ID of the model, and this is the client secret or key which can be used for calling that service. And by calling that service, you can get the prediction out of the system. And the implementation is really as simple as possible. Let me scroll down. There should be even some examples. Yeah, there are. So, like out of the box experience, you can have even some code samples, code examples how the web API can be used. In C#, which is kind of Windows native or Microsoft native, then in Python, and even how it can be called in R language. So you can just take it out, put it inside of your system, and let the system call the API. There is a, okay, let's take this one as an example. Yeah, there is an input definition. Input has to be sent as JSON. So there is an input definition and output definition, and you can even test your model by the simple UI. By clicking on test, you can get as simple UI as possible, where you write down all the features and you should get the label out of the system. As I mentioned before, there are two different calls against that API. The first is request response. By calling that, you can get one label per one data row. Using the batch execution, you can push the whole data set containing whatever, up to, I think, few billions rows, and let them calculate at once. For, let's say, more CXO person, let's call it like that, you can use even the Excel integration. So you can use your prediction by consuming it in Excel, or few other tools using the same interface as Excel is using. Okay, so basically this is it. Very high level overall overview, and few comments for that. The most common questions I've been answering in relation with Azure Machine Learning is, okay, how can we take already trained model out of the system? Just on time. So the answer is simple. You can't. And the reason why you cannot take it out, it's like it's tightly bounded with the infrastructure which was set up in Azure. Those boxes, let's call it boxes, are translated into some native code, not in something like R or Python, really in a native code. By doing that, we can, let's say, leverage the fact that native code runs better than some intermediate language. And it's also tightly bounded to the CPU power. So the response, or not the response, sorry. Odpověď. Answer. Thank you. The answer is really simple. You can't. So everything what you're gonna create inside of Azure Machine Learning has to stay in machine learning. But you can really separate your data and your system, which should use the code apart. Like the Azure could really just handle all the metadata and pre-trained model, and the real data can sit like on-premise or whenever. And by using that REST API, you can consume it literally everywhere. So this is about the taking model out of the system. And what's next? What important? Yeah. Yeah. What you can do is like clone your model and save it as a different version. So at the moment there is no direct version control included yet, let's say. So what you can do is to clone the model and have two difference, one deriving from the first one. So you can, let's say, overcome by doing that. So no version control. Retraining. I forgot to mention retraining. Retraining can be also part of the system, but retraining has to be done manually. By manually, I mean like has to be triggered from the outside. But triggered from the outside can be like even your system can trigger the retraining by calling some management API. The whole Azure has its own management API, and by calling that you can do literally everything with the Azure. So you can call that you can call retrain from outside, or there are some services which can be scheduled to force Azure Machine Learning retraining every, I don't know, 10 minutes, every week, every whatever. So retraining can be also be done by the Azure automatically, but not automatically from the machine learning itself. Okay, what else? What's important? I think, yeah, like this is it. Use it or not. As you saw, it's really like free of charge for testing. If you wanna use some advanced techniques like injecting your own script, you have to create Live ID, and with that Live ID you can sign up for free trial. For the free trial you have to enter the credit card, but just for identity verification. Nothing will be charged again the credit card. It's really like free. And in case you like it, and I hope you will, you can then use the paid version of the system. So, any questions, comments, anything?
What is the pricing model?
Okay. Let me show you. To be honest, I don't know. I don't remember by heart. So, Azure ML pricing. So there is some entry fee. Let me start with the entry fee. Machine Learning Studio, which is the web UI I've been working with, there is a monthly fee which is attached to that Machine Learning Studio, and it's like $10 per month per account. So this is like no matter how many hours you're gonna spend inside a machine learning studio, you have to pay $10 a month per account. Then there's a payment like $1 per hour of experiment hour. And by experiment hour, we mean like running the training. So once you hit run or train, not this one, no, not even this one. Once you hit run, it starts counting, and for each and every hour, you pay like $1, yeah, $1. And then the last part is the usage. So every single call is paid, and as you can see, it's 50 cents per 1,000 calls, and you have to pay even for computation power which is burnt during doing prediction. But in most cases, it's like follow some decision tree or something, so it's really very, very quick. So this is it. Real world example. I'm using machine learning because I'm kind of weirdo. I'm using machine learning for home automation, especially for heating control. So each and every room of our house has kind of 10 different temperature sensors, and they are pushing the data into the Azure like every second minute or something. So by doing some calculation, you can calculate how much data I'm pushing into the system. And all those data are used for prediction because we don't have the regular thermostat. We do have just buttons like, okay, I feel hot, I feel cold. And I'm adding those data into the data set, and then let the machine learning calculates what the temperature should be for each and every room, for each and every, let's say, part of the year, etc., etc. So I'm pushing that much data into the Azure machine learning, and I'm spending like $12 to $13 a month, including the fixed price for machine learning. So yeah, this is the pricing. Any other question or comment? Yeah. No, there's no way how to take out the there is no even some kind of visualization over the model. Sorry. Mean the parameters which are no, not really.
And for the feature transformation in the beginning, can you do complicated things like, I don't know, you have timestamp data and you want to parse it by month, by day?
Yeah, there are some transformations. Let's take me just one example. You can use some SQL transformation, for instance. So let me zoom a bit. So you can use multiple sources and combine them into the one, and inside of the transformation you can even split the columns, or you can add some columns or join some columns. So You can add columns from the outside, join together with some other data. So all those types of transformation you can also do by machine learning. To be honest, I saw even the applications like there were no modeling at all. They were using just the transformation because they were handling terabytes of data, which can be easily handled by something like machine learning because, as I said, you have nearly unlimited computing power, so you can use it even just like ETL solution or something like that. Yeah, I'm collecting the data by something called IoT Hub, which is special service, and its purpose is to collect the sensor data, especially as I'm using. And then from that service, I'm storing the data inside of Azure Blob Storage, which is the cheapest version of persistent storage in Azure. And from that place, I can take the data out into the machine learning. So this is how I'm training and retraining the model. And then the typical usage is like every 5 minutes or maybe 10 minutes, I'm not sure. I'm calling the API from my heating system at home and pushing the actual data, like interior and exterior data, and asking for prediction, okay, how the temperature should be in an hour, and based on that, I'm deciding like to heat up or cool down, and yeah, this is the setup I'm using. Anything else? Yeah. Yeah. The extension points are those, and because this is the full version, I can show it to you fully. Not this one. You can extend it with an R module or Python modules. So you can execute R script. So this is the one you can use, like zip everything together and then apply it. Actually not. By using this, you can create your own initial model, which can be purely written in R. And it could be written through the interactive window, or even zip can be uploaded. The same you can do, not the same, but you can also manipulate the data using some R packages and R scripts. So you can do the same type of manipulation as applying some SQL, for instance. So you can do it even with R script. And the last option is to do the manipulation using Python. So those are the extension points, and in the future we can expect like much more, but those are available at the moment. Okay. So there are two options. The first one is like you can create the really complex model and then pack it into, not a package directly, but let me show you an example. Which one? This one? Not really, but remember that step I were publishing the web service. Few of those components were merged or joined together into the one, which can be later used as a new feature, new functionality. So you can do the same. You can create very complex model and then store it as a prepared piece of functionality which can be reused by the others. I'm thinking about the idea of let's say machine learning store. It's not let's keep it for later out of the record. Uh-huh.
There is a box in the published to gallery. What does it do?
The first one I've been mentioning, like you can create your own model, which can, let's say, be a complex solution joined together into one box and then reuse. It's kind of combination, but as I said, better to keep it off the record because there are some, let's say, news comings and yeah. Anything else?
Can I model, let's say, the neural networks to specify how many layers?
Sure you can. Even if you use the simplest one, like I don't know, this one. For each and every box, you can specify some parameters, and as you can see, this is the part of the even basic configuration of the neural network. But you can custom. You can even do some custom definition, so you can really define the neural network from scratch, if you want. So yeah, you can. Anything else? If not, then thank you, and I will be available for chat for next, I don't know, at least an hour. So, thank you.